In this presentation, I will examine the effects of source to image distance, SID, and object to image distance, OID, on detail. In practice, you will find that distance from the object being studied to the image receptor, object to image distance, forms the basis of many positioning decisions. For example, why is an AP spine preferred over a PA spine? And when the object to image distance cannot be minimized, often a 6-foot source to image distance is employed to improve detail. I realize that magnification also plays a part in these distance selection decisions. Nevertheless, detail has its role. In this example, we have two identical anodes. A patient in need of examination, and below that, an image receptor. The small differences are in the patient. On the left of the patient is a point or an object near the image receptor, and on the right, a point much further from the image receptor. Now, let us extend the rays from the top and bottom of the focal spot for the left anode and observe the image projected on the image receptor. I chose these rays because they represent the extremes of disagreement. In reality, there are X-rays emitted along the entire length of the focal spot. When we repeat the same example with the right anode, we see a marked difference in the projected image. If I magnify the images, it's apparent that the image on the right is much larger than the image on the left. This is because the rays on the right have more time to spread before impacting the image receptor, creating a larger penumbral shadow, area of image and sharpness, and therefore losing significant levels of detail. You will find that detail loss due to excessive OID is second to motion in its ability to grade detail. Now let's explore the relationship between source to image distance and detail. Initially, everything is the same on the left and right examples. Even the points demonstrated within the patient share the same geometry, the tube and image receptor. Before we start this demonstration, let's move the right-hand anode closer to the image receptor, reducing the source to image distance. When the exposure is made using the left-hand anode, notice the path of the top and bottom rays projected from the focal spot. Again, tracing the path of the top to bottom rays in the right-hand anode, one can see that the image of the point is much larger, indicating a loss of detail. If we bring out the magnifiers, it's obvious that the right-hand image has significant loss of detail, the penumbral shadow being much larger on the right-hand image. So it is true, changing the two key distances, source to image distance and object to image distance, will both affect detail. The closer an object is to the image receptor, the higher the detail. Next to motion, the object to image distance has a large effect on detail. If you're asked why a position is done, either AP or PA, the answer is usually to increase detail or to minimize magnification by placing the object being studied as close to the image receptor as possible. Finally, Longer source to image distances will also maximize detail or decrease magnification, but in many situations, long SIDs are impractical, such as in tabletop work. Standard source to image distance for radiography is 40 inches to the table and 72 inches to the bucky. We have experimented with different distances, but 40 and 72 seem the standard across the industry. Thank you for your attention. This was Distance and Detail Lesson.